Powering our world, from wall outlets to tiny circuits. Our world runs on electricity. We plug our devices into wall outlets. Ever stop to think about what happens next? The electricity from the wall outlet is alternating current, or AC. Most electronic devices need direct current, or DC, to function. This is where power conversion comes in. It's a fundamental process that makes our modern electronics possible. Without it, our phones, laptops, and countless other devices wouldn't work. Power conversion involves transforming electricity from one form to another. One of the most common conversions is from AC to DC. This is done by devices called AC to DC adapters, which you probably know as chargers. But the story doesn't end there. Even within the realm of DC, different devices require different voltages. This is where DC to DC converters come into play. DC to DC converters are electronic circuits. They change the voltage of a DC power source. Think of them as adjustable voltage regulators. They take a DC input voltage and output a different DC voltage. They are small, they are efficient. This makes them essential for modern electronics. They allow us to power a wide range of devices from a single power source. DC to DC converters use switching techniques. This means they rapidly turn the flow of electricity on and off. By controlling the timing of this switching, they can regulate the output voltage. Imagine a water faucet with a valve that rapidly opens and closes. By adjusting the amount of time the valve is open, you can control the flow of water. DC to DC converters work in a similar way but with electricity instead of water. The need for conversion. Why can't we all just get along? You might wonder, why do we need so many voltage conversions? Why can't all devices just use the same voltage? Different electronic components have different voltage requirements. For example, a microcontroller might need 3.3 volts, while a motor might need 12 volts. Using a single voltage for everything would be inefficient and could even damage sensitive components. Think of it like using the same size wrench for every nut and bolt. It wouldn't work very well. You need different tools for different jobs, and the same goes for voltages in electronics. DC to DC converters allow us to use the right voltage for the right job. This ensures that each component operates at its optimal voltage, maximizing efficiency and lifespan. Buck converters are the workhorses of the DC to DC converter world. They are used to reduce the voltage. This is also called stepping down the voltage. They are commonly found in devices that run on batteries. For example, your smartphone likely uses a buck converter to step down the voltage from the battery to power the display or the processor. Here's how a buck converter works. First, a switch turns on and off rapidly. This switch controls the flow of current through an inductor. An inductor is like an electrical inertia. It resists changes in current. When the switch is on, current flows through the inductor and to the output. When the switch is off, the inductor tries to keep the current flowing. This charges a capacitor, which smooths out the output voltage. By controlling the on-off time of the switch, the buck converter regulates the output voltage to be lower than the input voltage. Section 5. Boost converters reaching higher voltages. Boost converters do the opposite of buck converters. They increase the voltage. This is called stepping up the voltage. They are used in applications where you need a higher voltage than the input voltage. For example, a camera flash uses a boost converter to generate a high voltage to charge the flash capacitor. Here's how a boost converter works. First, a switch turns on and off rapidly. When the switch is on, current flows through the inductor and stores energy in its magnetic field. Then, when the switch is off, the inductor's magnetic field collapses. This induces a voltage across the inductor, adding to the input voltage. This combined voltage charges the output capacitor, providing a higher output voltage. By controlling the on-off time of the switch, the boost converter regulates the output voltage to be higher than the input voltage. Section 6. Buck boost converters, the best of both worlds. Buck boost converters are versatile. They can both increase and decrease the voltage. This makes them suitable for applications where the input voltage can fluctuate above or below the desired output voltage. One common application is in solar-powered devices. The voltage from a solar panel can vary depending on the amount of sunlight. A buck boost converter can regulate the voltage to charge a battery or power a load. Here's how a buck boost converter works. It has two switching states, buck mode and boost mode. In buck mode, it operates like a buck converter, stepping down the voltage. In boost mode, it operates like a boost converter, stepping up the voltage. The converter switches between these two modes depending on the input and output voltage levels. By intelligently switching between buck and boost modes, the buck-boost converter provides a stable output voltage regardless of the input voltage fluctuations. Section 7. Isolated versus non-isolated converters, bridging the gap. DC to DC converters can be classified as isolated or non-isolated. This refers to whether there is electrical isolation between the input and output sides of the converter. Non-isolated converters provide no isolation. The input and output share a common ground connection. They are simpler and cheaper to design. They are suitable for applications where isolation is not critical. Isolated converters provide electrical isolation between the input and output. This is achieved using a transformer. This isolation is essential for safety in certain applications, such as medical devices and industrial equipment. The choice between isolated and non-isolated converters depends on the specific application requirements. Section 8. Applications of DC to DC converters. From smartphones to electric cars, DC to DC converters are everywhere in modern electronics. They are essential components in a wide range of devices and technologies. Here are a few examples: smartphones and laptops. DC to DC converters power various components within these devices, such as the display, processor, and memory, from the battery voltage. Electric vehicles, they play a crucial role in managing the high-voltage battery packs and powering various subsystems, including the motor, lights, and air conditioning. Solar power systems, they regulate the variable voltage from solar panels to charge batteries or power appliances. LED lighting, they efficiently convert the voltage from a DC power source to drive LED lights, providing energy savings and longer lifespan. Medical devices, isolated DC to DC converters ensure safety by preventing electrical hazards in devices like heart rate monitors and infusion pumps. These are just a few examples of the countless applications of DC to DC converters. As technology advances, we can expect to see even more innovative uses for these versatile devices. Section 9. Choosing the right converter. Factors to consider. Selecting the right DC to DC converter for a specific application involves considering several factors. Input voltage range. The converter should be able to handle the minimum and maximum input voltage from the power source. Output voltage and current. Determine the required output voltage and current for the load. Efficiency. Higher efficiency converters waste less energy as heat, which is important for battery-powered devices and high-power applications. Size and cost. Consider the physical size constraints and budget limitations. Isolation requirements. Determine if electrical isolation is necessary for safety or performance reasons. Carefully evaluating these factors will help you choose the most appropriate DC to DC converter for your specific needs. Section 10. The future of DC to DC conversion efficiency and beyond. The field of DC to DC conversion is constantly evolving. Researchers and engineers are continuously working on improving efficiency, reducing size, and enhancing performance. One area of focus is developing new materials and topologies for switches and passive components, such as inductors and capacitors, to minimize energy losses. Another area of innovation is digital control techniques, which allow for more precise voltage regulation and advanced features like soft start and current limiting. As we move towards a more electrified future, with the growing popularity of electric vehicles, renewable energy sources, and portable electronics, the demand for efficient and reliable DC to DC converters will only continue to increase. Section 11. Unleash your inner maker. Exploring the world of power electronics. Understanding DC to DC converters opens up a world of possibilities for electronics enthusiasts, hobbyists, and makers. You can use these converters in your own projects to power your creations from batteries or other DC sources. Experiment with different voltage levels for LEDs, motors, and sensors. Design and build your own power supplies for specific applications. Numerous online resources, tutorials, and communities are dedicated to power electronics and DC to DC conversion. Explore these resources, experiment with different converters, and unleash your creativity. By delving into the world of DC to DC converters, you gain a deeper understanding of how electronic devices are powered and open doors to endless possibilities for innovation.